Grade 9s. I know you guys are all studying really hard on your exams. I thought it'd be helpful to answer some questions from the exam review. And here's some questions that we're going to go through. So, number 7. Find the unknown interior angle or exterior angle for each triangle. Interior means inside. Exterior means outside. So, we know that all three angles add up to 180 degrees. So, the interior angles add up to 180 degrees. And when we see this triangle, we only have one angle. However, we see that these lines here mean that these sides are the same length. And when that's true, also true that the interior angles are also equal. So essentially this is x as well. So we know that 2x plus 50 is going to equal 180 degrees. So we can just solve for x now. So maybe move 50 degrees on the other side. So we subtract 50 from both sides. So we'll end up with 2x is equal to 130 degrees. Afterwards, we want to find out what 1x is equal to. So we just divide by 2. And we have 65 degrees. So we know this angle is 65 degrees. On the right here, we know that, for example, a flat line like here, we know from here to here is 180 degrees, because a full circle would be another 180 degrees, which would total 360 degrees, which is a full circle. So the goal is to find out how much we have in this triangle, and then we can subtract it from 180 to make a total supplementary angle. And so we can find this angle if we add up 91 plus 45, and then we're going to take it away from 180. So what do we got there? It's going to be 180 subtract 136. So we end up with 44 degrees. Now we know that 44 degrees goes in that corner there. So from 44 to this side will be 180. So we just take 180 minus 44, which is 136 degrees. So you can also see there is a pattern between this angle and the sum of the other two angles in the triangle. Question 8, it says calculate the area and perimeter of this shape. Well, let's break this into two parts. We got, call this A1 and we'll call this A2. So find the area of 1. It's going to be length times width. The length is 6 and the width is 4. So the area of 1 is going to be 24 square centimeters. Now we find the area of 2. We have this side length is 3. This side length is 2. So we do 3 times 2, which is 6 centimeters squared. So the total area will be A1 plus A2. So we got 24 plus 6, which is 30 centimeters squared. The next question here, determine the volume of each object. State exact and approximate answers. Lucky us, we get the formulas for all these beautiful shapes, so you don't have to remember or memorize any of these special shapes. So let me bring this one over here. So the volume of a rectangular based prism is the area of the base times the height. It's your job to figure out which is the base. If you want, you can call the base even this side. So the area of the base would be 4 times 4 times the height if we think of the height as that way, we can multiply that by 9. So our volume will be 16 times 9. And before you whip out that calculator, let's do the old school way. 9 times 6, 54. 9 times 1, 9 plus 5, be 14. So the volume of this will be 144 square inches. Well, sorry, not squared inches, my bad. Cubed inches, because we're working with 3 dimensions. We're looking at the volume. So again, you will be given this formula on the exam. The same goes for the cylinder. If we're going to be finding the volume of this cylinder, we know the volume is given here. The volume is pi, which is a number 3.14 roughly. Roughly, that means approximately. Times the radius squared times the height. The radius is halfway across the circle. So we see the circle up here. Halfway across is 4. So the volume is pi times 4 squared times the height, which is 10. So we got pi, 4 times 4, or 4 squared is 16, times 10. So our answer will be 16 times 10 is 160 pi meters cubed. And that's the exact answer. When you multiply that in your calculator, you might get a decimal number. So it should be around 160 pi. And finally, that last shape is called a cone. And again, you will be given the formula for this. So the volume of a cone is over here. We got the volume is pi times the radius squared. So basically this is the area of a circle times the height divided by 3. So it's actually the same formula as the volume, but exactly 1/3 of a cylinder with the same radius and the same height. So we're given the radius, we're given the height, we just plug it in. So the radius is 3 feet times the height, all divided by 3. So our volume is going to be 3 squared is 9. We can actually take 9. I'll write that in here. We get 9 pi times 12 divided by 3. Maybe I want to do 9 divided by 3 right away. That's going to give us 3. So our volume is 3 pi times 12. We got to multiply 3 and 12. That gives us 36 pi cubic feet. That's our volume. Again, you can pop that in your calculator and get a decimal by doing 36 times pi. Let's keep it going. This one here, surface area. So this question, you just have to find the area of each face of the triangle and add them up. Again, you'll be given the formulas for the area of each shape. I think the only tricky part is, I think in this one here, to find out this side length, it's the hypotenuse of this right triangle. So you're going to have to use Pythagorean theorem to determine that side length. And for all you exam studiers, if you want to write the answer in the comments below, just write question 15, surface area, and you can put your answers in there and see how you do. So question 16, how would the volume of a rectangular prism change if the side length doubled? So simply, you can take a rectangular base prism find out the volume. So find the volume of this. Maybe 4 times 7 times 2. And that'll be 28 times 2 is 56 centimeters cubed. And now just double the side length. So I don't know, maybe we want to double 2. So now that's going to be 4 times 7 times 4. Let's see what we get. 4 times 7 is 28. 28 times 4 will be 112 centimeters cubed. And when you look at these two, you'll see that the volume also doubled. Let's check out this one. What is the difference between fixed expenses and variable expenses? So fixed expenses, think about those can't change. Those are permanent. So when you think about, these are expenses that you can't live without. So for example, rent, perhaps food. Okay, those are two examples of fixed expenses. Variable expenses are expenses that will change over time, or expenses that you can kind of live without. Okay, so for example, variable expenses could be types of clothing. Okay, the list goes on. There's many more examples out there. Finally, missing side length of these right triangles. We have a right triangle, so think Pythagorean theorem. So we have a squared plus b squared is c squared. That's for a right triangle. Yikes, that is scary looking. That's a lot better. Where our hypotenuse is the largest side, hypotenuse, and it's always across from the right angle. So we see in this triangle it's upside down, but we see that the right angle, there's our hypotenuse. So in this case, we can do 15 squared plus 8 squared is equal to x squared. Once you simplify that, you'll get x squared is an answer, but you must square root both sides to get just x equals. So leave your answer below. Just call it question 42. A. Leave your answer below and compare to each other. Same thing for B. It's going to be similar. We can call this A. We got B already down there. We call this C because C is across from the hypotenuse. So we have a squared plus b squared equals c squared. Let's plug in what we know. A is 8. B is, we don't know B, just leave it as B. And then C is 13. We can simplify this. 13 squared, slipped my mind. What is it, 169, I think? Now you must solve for B. So subtract 64 from both sides. So b squared will be equal to 105. Well, we want to know b, so we take the square root. And a little task for you all. You can find out the value of b. Round to 1 decimal place. Okay. And the last one here. A diagram of a community ice rink is being shown below. The rink is being enclosed with a fence. How much fencing is required? So the fence obviously is going to go around the shape. Okay, so we almost have a rectangle, but we're missing this side. So the area versus perimeter comes to mind. Area is what's on the inside. Perimeter is what's on the outside. And last time I built a fence, I tried to surround my backyard. So we're looking at the outside. So let's look at the perimeter of this shape. So the perimeter is going to be, we have 26 meters. We have 61, but 61 goes all the way to the end here. So we got to find out how much we need to take away. And we can do so by looking at this line here is actually the same distance as this line here. This is called the radius. This is the radius of the circle. And the radius of the circle is the same from the middle point to the outside of the circle. So these are all examples of the radius. They will be the same distance. Pardon my chicken scratch. So we need to find the radius of that circle, or the half circle. We know that 26 meters would be the entire length. So we can say the radius will be 26 divided by 2, which is 13 meters. So we know that this is going to be 13 meters, which means that this here is also 13 meters. So to find the side length of the rectangle, we need to take 61 minus 13, which is going to be 48 meters. So we have 26 plus 48 plus 48, because there's two sides that are 48. And we need to add the outside of the circle. So this is for the rectangle part. But we also need to find out what's the perimeter of a half circle. So the perimeter of circle is pi times the diameter. And since we have a half circle, we're going to do divided by 2. So that's going to be pi times 26 divided by 2. So essentially we'll get 13 pi. So we can just add that to our top part. And our final perimeter, if we add up everything, what do we get here? We get 26 plus 48 and 48. That's going to be 156. So we got 26 plus 156 plus 13 pi. And I'll leave that one up to you guys to figure out. I'm not going to show you all the answers. I'm not teaching you if I'm just giving you the answers. So hopefully that video was helpful. If there's any more requests out there, just write the comment below. All right, good luck studying, guys.